In this project, we will investigate the fluid flow problem and heat transfer inside a pipe in 3 dimensions. Now, as you know, the first step is to click on a fluid flow block and then drag it into the blank space inside Workbench software and then double click on Geometry section. Now, in order to design the cross section of our geometry, we click on XY plane and then click on the Sketch button. After clicking on the sketching button, we click on Circle and then draw a circle in the middle of our coordinate system. Now, after drawing the circle, in order to give dimensions to the circle, we click on Dimensions and then select on Semi-Automatic. Now, under the dimensions, we enter the value of diameter of our circle to be equal to 0.05 meters. Now, after drawing the circle, which would be the cross section of our pipe, we click on Extrude button and then extrude this circle with a length of 2 meters. The next step is to create a rectangular cross section in the middle section of our pipe. Now, this rectangular cross section will be used in meshing section to generate a structured mesh easily. To create such geometry, we click on XY plane and then click on the sketching button. To create such a structure, we click on sketch number 2 and then click on the sketching button and then select rectangle and then draw a rectangle in the middle section of our coordinate system. Now, this is the surface that we have created in previous slides. In order to change this face into a line, we again need to create another isosurface. In the appeared window, we follow the same steps that we used in order to create the previous face, but this time with the difference that under the surface section, we select the outer wall boundary in order to make the software understand that we want the intersection of this face with the outer wall boundary. Now, in this slide, you can see that the intersection line that we needed is created and shown here. Now, in order to calculate the value of surface heat transfer coefficient, we need to have two values of bulk temperature and wall surface temperature. To calculate these values, we double click on Surface Integrals button. Now, in order to calculate the value of the temperature over the created line, as you can see in this slide, which is placed on the geometry, under the report type, we select vertex average, and then under the field variable, we select temperature, and under the surfaces, we select the z coordinate number 7, which represents the created line, and then click on Compute button. Now, as was mentioned earlier, we need to calculate the bulk temperature. To do that, we change the report type from vertex average to facet average, and then under the surfaces, we select the surface that we had previously used to create the line that you can see in this window, and then click on Compute button. Now that we calculated the values for wall temperature and bulk temperature, we can easily put those values in the formula for the surface heat transfer coefficient and calculate its value. After that, we can easily put the value of the surface heat transfer coefficient in the Nusselt number formula and calculate the Nusselt number manually.
To benefit from Mr. CFD services including simulation, consultation, and training, contact our experts via info@mrcfd.com.